effect of absorption. Write the subheading effect of absorption. Effect of absorption. I think the word is explaining it. Absorption means certain amount of power of your signal will be absorbed by air molecules, various molecules which are present in the air. The atmosphere, although it looks very free, the air has various particles like oxygen molecules, nitrogen, and there is a composition. And certain molecules attract some frequency, and they absorb energy from those frequencies. Therefore, there is a certain amount of decibel attenuation over here. When it rains, there is more attenuation, which we call rain attenuation, rain absorption. So likewise, absorption is due to various particles in the air. You can write certain amount of energy. RF signal, certain amount of energy of an RF signal get absorbed by various molecules. Get absorbed by various molecules. Present in the air of troposphere. Present in the air of the troposphere. It causes a certain amount of dB loss, certain amount of decibel loss per kilometer of travel, travel. It depends on the frequency. Depends on the frequency of the signal. That means the loss is changing with frequency. You can plot it as a graph. On the horizontal axis you can take frequency, vertical axis you can take absorption loss per kilometer. And then with the frequency you will notice the loss increases, absorption loss increases. Because the wavelength becomes smaller and smaller, and when the wavelength becomes close to the particle size, the absorption becomes more. So when you plot, it's a graph like this. It is for different amount of densities, like rain, mist, water vapor, various things. But in all cases you can notice there is kind of increase of absorption loss. But the losses are very small. It's like dB per kilometer. Maybe it's about 1 dB per kilometer. So below that 1 dB level. But suppose you are going for 50 kilometer or 100 kilometer, it becomes significant. 1 dB per kilometer multiplied by 100 becomes 100 dB. So that can be very significant in certain long propagation length. So on new line effect. Part of the atmospheric absorption is due to water vapor. This is the water vapor. Vapor. VAPOUR. Water vapor present. Water vapor present in the atmosphere. Water vapor present in the atmosphere. Example, humidity. Humidity means amount of water vapor on air. Humidity. Right now we have humidity in this room, means water vapor present in the room. Then we have mist. Then we have fog, thick mist. Then we have rain. Likewise, those are all water. All water present on the earth. In addition, different air molecules absorb energy from different frequencies. Absorb energy from different frequencies. So raindrops usually absorb energy like that. This is the total absorption loss. When you plot, you can see a gradual increase. Higher the frequency, more will be the absorption loss per kilometer. That is one observation. Another observation is there of these, like at 22, this is actually 22 because water vapor is resonating. So you can't use 22 because it signals over long distance. Then around 60 gigahertz, oxygen molecules are resonating in there. Then 120 again oxygen. About 160 there is another water vapor. So likewise, those frequencies where the absorption rate is high, you should avoid because they will anyway be absorbed by the air and your received signal will be poor. So knowing these frequencies will be useful, that is one. Second is this gradual increase of flux. So shall we approximate the flux? Vertical axis is absorption loss. Approximately mark this value. 10, 100, all dB is in kilometers. So you can see frequency is like say 100 giga. We'll have about 1 dB per kilometer or less. Therefore, they cannot be used for long distance. 50 dB means additional 50 dB absorbed in the sun. 50 kilometers. 50 dB. The frequencies in this region and this region are quite okay, and they are very popular for microwave links. So you can mark this region by a dotted line, and also this region by a dotted line, and then put arrows to those two regions and mention these are popular for terrestrial microwave links. Popular for terrestrial microwave links and SATCOM. Because the absorption is very low in this region. So these frequencies are not popular because their absorption rates are high. Do you remember when we study optical fibers in the diploma, we plotted a similar graph. We plotted attenuation versus wavelength and found that three wavelengths are suitable for actual operation: 800 nanometers, 1300 and 1550. What did we do actually? We were studying the glass as a material, and within the glass we found some frequencies are unusable. Same thing here. Like the glass here, this is air, and when we plot the air absorption, again we find certain frequencies have very high loss, and we avoid them. Low loss ones we use. Same idea like what we do in the optical side. If you are smart enough, you will see the similarity of these two things. Also, we did it in two different subjects. Each time we studied the material. Within the material, we found there are certain frequencies absorbed. Okay? So compare like that and try to enhance your understanding. Okay? The loss increases, or that the loss increases with the frequency, with the increase of frequency. The loss increases with the increase of frequency. So, sir. In addition, there are certain resonance, RESONANC, resonance, resonance, peak, 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 in the graph. Example, water vapor resonance at 22 gigahertz. Water vapor resonance at 22 gigahertz. Second one, oxygen resonance at 60 gigahertz. Oxygen resonance at 60 gigahertz. Etc. Then there were more. New line. The rain attenuation also increases with the frequency. Like this. This is rain attenuation. In dB per kilometer, this is dB. is thick rain. Thin rain. When the rain is very heavy, like in Sri Lanka, normally it is thick rain. It's a higher loss per kilo. Just draw the shape. But you can notice different thickness of rain. When you plot, you get different types of graphs. But I am just drawing one or two. That's the rain one. This is rain 26 millimeter per hour rain, 7 millimeter per hour rain, 65 millimeter per hour rain, like that. Rain is measured in millimeters, you know, millimeters per hour. And when that value goes high, the rain is very thick. And in Sri Lanka, usually you get very thick rain. One of the thickest rains in the world in Sri Lanka. So normally we have to estimate higher rain loss than other countries. In countries like Europe, the raindrops are very, very thin, very small. But our raindrops are big ones. So when the raindrop size increases, the loss increases. Okay, next one. How do we accommodate this loss in our equation? Free space loss. Earlier I had the equation. Free space power budget was there. How can you modify that link power budget to accommodate absorption loss? New line is there. The link budget used for free space propagation. Link budget used for free space propagation can be improved by including absorption loss. As shown below. By including absorption loss as shown below. We took a power line PC. Then we added DC to that. We got the area here. We had the free space loss. After free space loss, we will have another loss. This axis of course is not needed. We can have another loss which is called absorption loss. After that, we will have the gain of the receiving end. What do we get here? Received power. How to modify our calculation. Earlier we did not have this loss, but now it is our modification. This is modification means that dV will go down due to the absorption in the troposphere. It will not happen in the plate space. So that's how to tackle absorption in the calculation. Slight change will be there in the equation now. The equation will be therefore Vc plus Vp minus Vc plus minus absorption plus dr. Now we move on to the second effect. We said there are two dominant effects. One is absorption, other is, what is the second one? Out of the two? Refraction. Right? So we are moving to refraction. Shall I something? Effect of refraction on space. Effect of refraction on the space wave. The effect of refraction like this you have already noticed. You don't need to draw. You know that anything in the water appears little higher than where it is, due to refraction in the surface. I am sure you have seen it many times, so you have observed that effect very much, and that is due to refraction, bending of the waves when the wave travels from one medium to another medium. So let us define refraction like that. Refraction is the bending of the wave path theta, bending of the wave path when it travels from one medium to another medium. From one medium to another medium. And when we studied optical fiber, you might remember that we studied the core area and the cladding and found that when you send it with the angle higher than the critical angle, it will be going to total internal reflection. Less than the critical angle, it will be going to the other medium. So all that is part of the theory which we are not going through now. So we have done it under the diploma in the fiber, optical fiber. Professor Chan mentioned, refer to the theory done in optical fiber in diploma. And in optical fiber communication in diploma. Fiber communication in the diploma. So we move from there, we are not rewriting that again. We will define refractivity now. In propagation study, we use another definition called refractivity, which is not exactly refractive index. Refractive index, I think you understand from the optical fiber discussion. It represents the density of the material also. Higher the density of the material, more is the refractive index. You know, glass has 1.5, air is 1.0003, free space has refractive index of 1. So likewise there are different refractive index values. But because the value is so small, we normally use something called refractivity when we study propagation. You can mention. In propagation studies, in troposphere, there is a refractive index for the air in standard atmosphere. For the air in the standard atmosphere. In the standard atmosphere. The refractive index is 10. Free space, and you need 1.0003 for troposphere, for lower troposphere. Lower troposphere under normal weather is known as standard atmosphere. Another name for that. Another name is standard atmosphere. And in the same standard atmosphere, this value keeps decreasing when you go up. Because the air density is reducing with height, it is decreasing with height. That decrease is given as a refractive index gradient. You can write. Simple n decreases with height. Simple n decreases with height. With a gradient of change of n per unit change of height. Change of n per unit change of height is very low, minus 0.039 10 to the minus 6 per meter. Every meter you go up, use this number. But these values being very low, we define slightly different value called capital N, refractivity, for our study. So you can do it. For propagation study, we define another term called refractivity. Another term called refractivity. Within brackets capital N. Refractivity capital N. Close bracket. In the following. Refractivity capital N in the following manner. find capital Nx, simple N minus 1 multiplied by 10 to the power 6. Simple N minus 1 multiplied by 10 to the power 6. So on the surface then, value is 1.00303. If you substitute here, that will be capital X. 1.0003 minus 1, that means 0.0003. Then you multiply by 10 to the power 6 to get the answer 300. So in the surface of standard atmosphere, refractivity is 300. In the refractivity at the surface is 300. Then this one, it becomes 39. 39. This one you don't need to write, just to show you some relationship that capital N refractivity has been studied thoroughly by people, and this is the relationship we find how refractivity will change with the air pressure and the air temperature. P is the pressure, T is the temperature, and when those things change, the refractivity of air continuously changes. But it's beyond our studies here. But I want you to understand that refractivity is not a constant. When the weather changes here, the pressure and the temperature changes, refractivity will also change. Therefore, that value I gave you, 1.0003 for N, which becomes 300 when it comes to capital N, is just for a standard atmosphere. It is not a constant. It will go up and down due to these changes, pressure and temperature. Just understand like that, but we are assuming it as a constant for city and gives work. Right? So on a new line you can write. However, capital N is a function of the air temperature and air pressure. Air temperature and air pressure. When you plot that refractivity of troposphere with the height, I am taking height up because it's easy to understand when you take height up. Height is anyway upward. Then if I plot the refractivity in the horizontal axis, our 300 is somewhere here on the surface. But when you go up, because pressure decreases, refractivity is decreasing like this. Refractivity comes down as height goes up, and it's a little curve, so you can draw it like this. How refractivity changes with height. But with a curve like this, we can't do our calculations easily. And in any case, we don't want very high values. Our antennas are about 100 meter tower or whatever. Right? But actually, this is exponential curve. Actual equation is something like this. But we are not taking it that way because it's too complicated for our work. Therefore, we simplify it like this. For lower height, we can approximate it to about 1 kilometer from Earth. if I draw a horizontal line at about 1 kilometer on this graph, that's where most of our communication towers are. So draw a horizontal line, then this area is more like a straight line. So it's easy to assume a straight line than to curve. So we are taking it as a straight line, which is a tangent to this curve, which you can draw yourself. Mathematically it is easy to draw the straight line than curve. Then if you look at that gradient, there is a negative gradient now, refractivity decreases with height. That is the value I have given. Because I have given it you with n, capital N, it is the value like this. It's minus 39 per kilometer. dn over dx is minus 39 per kilometer. But that value is minus 0.039. If you want refractive index, refractivity decreases easier, it is minus 30. Just mention the value here 300. Use 300 here. And the value here at the end of after 1 kilometer it is 300 minus 39. Which is how much? 261. 261. So write those two values. And then you approximate it to a straight line. Why are we worried about this decrease? Because when you send a wave going up, it is going from dense air to rare air, isn't it? Dense medium to rare medium. So according to your knowledge now, what will happen to the wave? They will change the path and gradually bend, isn't it? If the wave will bend, what is the problem is it will miss the receiving angle. You can't focus into the receiving angle. You may mount on two tower sides, and in a good day like this, you align the antenna system perfectly aligned. And tonight, if it rains, or if there is mist, there will be more bending, and it will miss the alignment. So those are practical problems we face. Practical problems are that due to the gradual bending, your signal strength you expect will change when the weather changes. Even in the standard atmosphere, it is not when you align, it is not directly aligned like this. It is slightly aligned higher. So that energy will go this way and come down. This is how the antennas are aligned. You can see, notice it, very slight alignment upward. Because it is the wave going up which will be actually coming down due to bending. It's not a straight line. What I am trying to say is that if you assume that the energy travels in straight line due to space wave in the troposphere, it is wrong. Maybe in the diploma we said that. Maybe in the certificate you studied that space wave travels in straight line. But it is not. That is why we are worried about it. It is not because of this. Because refractivity is not a constant. It is decreasing with height. Therefore, there is slight bending of the wave while it travels. So please clear your idea that phase wave will be in straight lines in troposphere. It will be in straight lines in the phase wave, but not in the troposphere. Not in the troposphere. So that's how we expand our knowledge boundary. Right? Earlier we studied it is straight and study basic ideas. After that we learn it is not straight. Slight bend. And how much is the bending? We can calculate. We are trying to do that actually. How much is the radius of this bend? So we slowly adjust our thinking to the correct situation. That's how we go back. I am showing the certificate you studied otherwise. You said the ground wave travels along the ground, sky wave goes up and gets bent, space wave travels in straight line. So, truly speaking, there is an error in there. And that is why they call this level advanced diploma. They want you to think about the same thing little bit advanced, little bit analytically. Assuming that you have developed your thinking capability above certificate level or diploma. So that is the expectation. Therefore, don't try this exam with the same mentality that you had with the certificate or the diploma. You can't play the same stroke here. You will get bored. You have to change your stroke and refine it further. Like a professional, a better stroke should be practiced. But basic strokes are same. You are correcting it now. That's the only thing. So same idea here. When you study to a higher level, it means that the analytical ability of our thinking should be increased. It's easy for me to say, but you might wonder, how can I increase it? How can I increase it? I am same me, isn't it? That's how you might think, but you are not the same you when you come to the advanced diploma. Because you have more confidence, okay, I have finished diploma, now I am ready to go a little up and be more inquisitive and find out exact details. Have that mentality. Inquisitiveness is very important. That will make you ready for a higher level. Right? Thinking is a game, isn't it? It's a game. And it has certain patterns. If you study, you can change them. You can change them and improve. While I repeat this, because some of us will not understand there is a difference. You might think, okay, I am me and this is my ability, and I am trying advanced diploma also. Don't have that mind. Don't have that mind. When you try advanced diploma, what you have to adjust is thinking, I am not the same me. I have to improve. I am going to improve and come up to the level of advanced diploma. I am not trying advanced diploma. I am coming up to the level of that and doing that thing. That is the internal adjustment we should do. So don't practice the same cramming method and same way of studying that brought you here. That is past. That's gone. And you have to adjust your thinking a new way. Then only you will be very suitable for the advanced diploma exam. These are little examples where we initially thought it is a straight line. So slowly once we study refraction, we know it can't be. It is bending. And then comes the question, how much will it bend? Can I calculate the radius? If I know the radius, will it help me to align a microwave length? So that's how we have to be inquisitive and go for more and more explanation on the line. Okay. So I am trying to generalize what we are doing here. Generalization is that we are looking for detail. And there again we do little approximation. It is a curve, but we are approximating it to straight line. There is another little error. Still little error. But modern software even correct that error. We will come into that situation. Did I show you some software which is doing all this calculation? In the diploma? I think I showed. Showed where the path profile kind of calculations can be done. How these theories have come into software and how you plan a link. Had everybody seen that? You saw it. Others? Maybe some are new, so you might not have seen. I'll search here. It's somewhere there. I'll search and put you later. All these theories are practice. Practice in the form of planning software. Okay? And good planning software for signals, there is one software called Planner TV, which is very good. Another one called TEMP, and there are a few new ones also now. Radio system planning is another software. So in those software, these things are built in. You have to enter your parameters and get it adjusted for your plan. So remember, we are not studying a theory, we are studying a practice which is already being used in planning, microwave links, planning cellular base stations, etc. Although there are few equations coming, it's a practice. Okay. This is what happens to the signal when it goes over the earth is bigger bend curve, but signal is also bending a little due to refract. Right? As a result of the dn over dx, as a result of dn over dx, the tropospheric space wave undergo gradual refraction. And as a result, its path gets bent, B-E-N-D, gets bent towards the earth. The path gets bent towards the earth. And we will show this. Earth radius is 6378.16 kilometers, but the radius of this bending is given by this formula, which is beyond we are not going to prove this, but when you substitute standard atmosphere, this much of kilometers radius, that is the bending. If you know differentiation theory, you can prove even this formula, but it's beyond our syllabus. Don't worry about it. Maybe when you study to CEI level or graduate diploma level, you can study that part of the theory. Okay? Don't write this sentence. Just mention below this earth radius. Below this you can write. Even this equation you don't need to write, just write value. Approximation is fine. Below this you can write radius of curvature of the path. Radius of curvature of the path. plan that equation, right? Don't plan this equation. I'm just putting this to show you that it's related to dn by dh and nc. But you don't need to plan this. Just mention approximately 25,780. Approximately. Why approximately? Because when the weather changes here, this radius is going to change anyway. It's the approximate value. So that means if you know dn by dh, you can calculate the radius of bending of the wave. And that is needed for your planning of the wing. Sometimes in the exam they ask what is gradual refraction. Maybe a diagram like this is there. The air can be thought of as a little layer. And when you go up, dn by dh is negative. Therefore, a wave entering at an angle like this is bending here and this is bending here. That's why it will go on. And this kind of gradual bending is what we call gradual refraction. Finally, the angle will be so high, it will be total internal reflection to turn other way around. So these air layers are like delta for dh height. Little height of dh for each air layer, and dh is very small. Very small. So if the examiner asks what is meant by gradual refraction, please draw this kind of a diagram and explain. How many of you are interested in doing advanced mathematics? Already three, right? Only about 5, right? Because there is a request whether we can do advanced mathematics also for the exam. You want to? No. If you want to do, maybe you can give the name. Then what I can do is I can check with the final year student of the university and try to organize a separate class, because we won't be able to cover the syllabus of radio when we try to do 2 months. Okay? And advanced mathematics is an optional subject which you need to do, especially if you want to do higher studies. They advise you to do it if you want to do higher studies. So if there is sufficient demand, then I'll try to get it organized, but not here. It will be at Lear, the other place. It's a final year student of the university. But if the demand is very low, we'll give it up, okay? Because it may not be economical to do it. So in that case, maybe self-study or something might be required. So please give your name before you go, so that I will see how much is it. Okay? And also the date starts satellite communication for 7th February. Optical fiber course is just finished for the dialogue, and we did it for dialogue earlier. We'll repeat later, not immediately. Microelectronic PIC programming course has just started today. So if you have any friends who are interested in these areas like optical fiber, SATCOM, big programming, Java, C++, they are all running in parallel there. Just let me know, then I will give you the contact of the lecturer who is actually doing it, and then you can talk to him. And so tell your friends also as much as possible. Coming back to this, refractive index change has caused the bending of the path, but with this kind of a bend path it is difficult to plan. So what we do is, we somehow try to maintain relative curvature between these two. If the relative curvature is maintained, then our calculation will be correct. So since the earth is curved already, what we try to do is, we will maintain relative curvature and make this a straight line. If this is straightened, what will happen to this? Imagine, we are not going to straighten it. But if the upper one is straightened, if the relative curvature is to be maintained, what will happen to Earth? Will the Earth radius be increased or decreased? Just think about it.
Refractivity can මේකෙන් අඩු කරලා මේකෙන් නම් ඉතිරියට කරලා දැන් මේ මෙතන මේ DN මෙතන ඒ අර අනිවාර්ය අවකන්නේ අවකන්නේ අර දැන් එන්නේ කාට වෙනවා ඔව් දැන් refractivity එක අඩු වෙනවා අර සංස්කාරේ ගන්නවා නෑ මේ යන්න අපි නෑ refractivity එක DN value එවැනි නම් මේක අඩු වෙනවා කියන කියලා කියන්නේ මේ බෑ ස්ටොප් එක දැන් මේ හරිය ස්ටොප් එක මේ ගන්න තව යනවා මේක ස්ටෑන් ඇලවෙන ගන්න ඒකට ඕනේ මේක එන්ජින් එක වැඩි වෙනවා ඒක අන්තිම නෙගටිව් මේකට අපි ඩිනාමික්ස් ඕනේ නෑ මේ DN value උත්තරේ දිනා වෙනවා මෙහෙම කියොත් මේ වැඩි වෙනවා මේව මේ අතර හොම වැඩි වෙනවා
the earth radius increase? If the red line is straightened, maintaining the relative curvature, what will happen to the earth radius? Will it increase or decrease? Imagine. Relative curvature must be the same. With respect to one, the other curvature should be same. So shall we do the calculation then, if you are doubtful? Increase. Earth radius will be increased, but some of you have doubt, I can see from the faces. Okay? Maybe you are reluctant to modify the earth like this. Okay? You might be wondering what will happen to me if I modify the earth. Okay? But we are not changing the earth radius, we are just imagining. Right? Imagining. Anyway, let us do it then it will be clear. If there is a arc like this with a radius of say r, how do you define curvature? Curvature means geometry. Curvature means not r. Curvature means 1 over r. Curvature is always defined as 1 over radius. Remember that in geometry, curvature of something is 1 over the radius. Just mention it. The curvature is, but this is not needed for city angle. This is only for your proof, right? Only for your concept. The curvature of a line is given by 1 over the radius. Curvature of a line is given by 1 over the radius. Therefore, the relative curvature in this system relative curvature in the verb system is the curvature of Earth, isn't it? A is the Earth radius, 1 over A is the Earth curvature. From that I will subtract the curvature of the curve, the path. Now I get difference in the curvature. Difference in the curvature means relative curvature. Which is that? Okay, master may because don't time this for the CTNS exam. Right? They don't want you to understand these things. Maybe you have already noted that in order to do a job, you don't need to get all knowledge, isn't it? And if you outside this, suppose knowledge is an exercise. If you want to do a job, you have to pick up this part of the knowledge and a little bit of this and a little bit of that, a little bit of that, and put that into your head, and you become some person. But EBC, there will be a lot of things that you don't know. But some people think that if knowledge is an exercise, if you learn this much, you can do one job. If you extend this to this much, you can go to a higher level. That is wrong. That's not the way people do jobs. In the knowledge axis, you select information here and there, and you make a job for that. For example, you might see somebody like a mason working there in that building, right? And he might not know everything about civil engineering. He will only know how to put the two mixtures, and they are doing it right now. Right? How to put fan and what is the ratio, and then do that, and then they know how to finish. So little knowledge here and there. Although they are using cement, they don't know what chemical composition is there in cement. So that means some knowledge about cement is missing, isn't it? And they know how to finish, and that some technical methods of finishing they might not still know. So in some other countries they don't finish the buildings like this, they have a machine for it. These people may be unaware. Basic knowledge. Then how to handle money, again some part is there, some part is missing. So when you select the knowledge from here and there and tie them up together, you can do a job and earn money. Nobody completes all knowledge before they start a job, isn't it? So you will also be like that. And when you want to make when you want to give a raise to this person, but you expect him to increase this part little bit, increase this part little bit. Then you become a middle manager. Still there are a lot of unknowns. Diploma and advanced diploma are also like. In the for example, in this theory I am teaching you that these are bending like this, but I am not teaching you how did this come. How did this come? That will be a different course. CEI course or something. So that means when you finish advanced diploma, you will have this idea, but you will not have an idea of how did that radius of curvature come. And that needs a higher course. So you are extending the boundary a little bit there. So that's how it happens. So CTNG syllabuses are organized in such a way that you pick the knowledge from different areas, little bit, just sufficient to carry out the job of the diploma holder, or advanced diploma holder. So therefore, don't expect the knowledge to be continuous. If you expect that, you will be frustrated with CTNG. You will give up no more. Because CTNG syllabuses are not ordered that way. These are vocational qualifications. Qualifications for a job. And therefore you pick the knowledge which are required here and there for the job, integrate it into a syllabus, and that is your diploma. But you won't have knowledge like a degree where the things are starting from a particular level and slowly increase. That won't happen here. If you expect that kind of clarity in city and guild syllabuses, you will be frustrated. City and guild syllabuses are not made for clarity. Not made for clarity. Not made easy for you to understand. But instead, syllabus is made for you to do the job. Get ready to do the job. So therefore, when you go through the course, there will be certain little pockets like this where the certain parts of the theory is not covered. And some of you might be worried, why is it not covered? Then it is not clear to me. Don't think like that. It is not covered because it is not required for the advanced diploma holder to work as an advanced diploma holder in the field. So it is giving only the required knowledge. That's the theory of vocational qualification. Please understand what you are going through. Okay. Relative curvature we work on a new line, you can say. Let us straighten. Straighten the path of the radio signal. To be a straight line. While maintaining the relative curvature between the two. So you can draw it like this. This time equivalent system I explained this. As a result, I have to modify my earth radius by a factor k. So this is modified earth radius. Is k times the earlier earth radius. K is a factor by which I modify my earth radius. This is to make mathematics easy, that's the only reason, right? Okay, so can you write the relative curvature for this system now, like earlier? Therefore, relative curvature, can you write it? Relative curvature is, what is the curvature of this one? 1 over Ka. Just modify this. 1 over Ka. Minus 1 over, what is the radius of this? Infinity. Radius of the straight line is infinity. So 1 over Ka minus 1 over infinity. 1 over infinity is 0. Therefore it is 1 over Ka. Then you can equate the two. Earlier relative curvature was this. Earlier it was this. Now it is 1 over Ka. Can you find what is K from this? Simplify and find what is K. Then you can identify how much should I modify the earth to straighten the path. So can you equate and find K? Right. So what is K? Just mathematics after that. K becomes R divided by R minus A. Did you get it? A is R divided by R minus A. R divided by R minus A. Shall we substitute standard atmospheric values? Substituting by leave that derivation zero. In legal mathematics, which you should have known before coming to advanced diploma class. I am not going to an inline concept. Substituting standard atmospheric values. Standard atmospheric values. R, I gave you the value earlier, that 21,000, 25,000 something. Please write that. A is 6370 approximately. So if you substitute them like this, the answer you will get is 4 divided by 3. So substitute that earlier value I gave you for R. Simplify and see, you will get the answer 1.33, which is equal to 4 by, which means that for standard atmospheric condition, if you increase the earth radius by 33%, you can draw the signal as a straight line. If you use the exact normal earth curvature, you have to draw the signal also curved, but curved signals are difficult to draw. Solution is, let us make the curve straight, signal straight. As a result, earth will be modified with a radius which is 1.33 times higher than the normal earth radius. So that is how the refraction is taken into account. Refraction is taken into account by increasing the earth radius when you are plotting the path. Okay, equivalent system. Now, for example, this kind of software, the software I may have already told you, which is what I am using for planning. This earth is plotted with the modified earth radius. Although it is showing us as a straight line, calculations are done with the modified earth radius of 1.32. In fact, the software will ask me what is the radius you want to enter, because I can even change that. And then you will see whether there is a line of sight, path from link. For example, I have substituted Bambalapiti Setkava here, and Yadyampata mountain there, and you see the path going over from Bambalapiti to Yadyampata. And it calculates all signal strength based on this theory we just did. For example, any place you want to study here, it's Yadyampata on the map, and the height at Yadyampata you can get as about 1,000 meters here. About 1,000 meters. It is the height there. And this is the path. And you can find out over what area it is going. For example, if I just click on this, and go to different places, you'll find that also moving. Did you notice? Signal strength gets recalculated for every point over the line, and that exact point is also shown here. So this is the final. Why I showed you this is the final outcome, final tool of this theory, coming out of this theory that the engineers will use. In fact, this is an actual one I am using, right, for planning. But to understand and work with this kind of tools, you have to understand this basic theory, because the tool will ask you various questions and you should be able to answer. And you are training for that. This little knowledge we get will be later very useful to handle this kind of tools for propagation planning, coverage planning and everything. Right? That's why I wanted to show you. And this particular diagram automatically takes a modified earth rate by 1.33 times. So you can write there. If the earth radius is increased, by a factor of 1.33, we can draw the path as a straight line. This accounts for the accounts for the effect of refraction. Okay, now our original question was, we studied phase space, and what will be the change in the troposphere due to refraction? This is the effect. Effect is, it is no more a straight line, but we have to draw it as a straight line for planning purposes. Therefore, the best way to account is keep it straight line, but modify the earth radius to account for the relative value. Keep the relative value. So that's how path planning is done. Path planning is always done by drawing a straight line between the two stations, but on a modified earth, not the normal earth. So now you can see how difficult it is to account for this kind of effect, isn't it? Mathematically it's very tough. Right? But now software tools are available to do the calculation, therefore calculation is relatively easy. Understanding the principle is a task that we have to complete now. So we have completed two tasks now. One is how to account for the effect of absorption. How to account? We drew earlier the link power budget, and we add an additional loss called absorption loss. So many dBs per kilometer, and for the kilometer number we have in our link, we can find out how much will be that additional path loss. So there are studies by the ITU about the rain loss and various losses, and the curves are there. You can get the loss from that curve and add that into your link power budget. Your calculations will be more accurate. Second thing we were studying was effect of refraction, and now we know how to do it. We don't modify our link budget. Instead, we modify the earth. For the drawing purposes, we modify the earth, and on the modified earth we draw the mountain, and then draw the path as a straight line, and that will do the job. Right? So those were the two problems we decided to tackle: effect of absorption, effect of refraction. Other three are even more complicated, so we are not tackling it immediately. Okay? But when it comes to cellular communication later, we'll try to tackle the effect of reflection. That is very tough to handle it by electronic search. Anyway, we are doing it when it comes to the WCDMA theory layer. Okay, that's all for radio today. But I want to introduce the project within 15 minutes, just the introduction. So it's time for us to start today. Okay, Telecom project. Without this, your exam will not be complete. If you plan to do CEI or something, you must complete the project also. So, project is something you have to spend 160 hours on your own. Supervisor will be available, like I can supervise by giving guidelines. So this is part of that. What I am trying to do is part of the supervisor's job. But job is yours. This is yours. And the job is given a number by city and group. It's called 273-021. It is the exam you should apply on the project. Okay? So maybe have a different note for telecom project. This is where you have to be careful because you might not be starting it. You may not be starting. Yesterday, day before, I had a visitor to the department, Marathur, Professor Jagat Samarbandhu, who studied with me long time ago, and he is now in Canada, in Western Ontario University. And in a recent visit, we invited him to do a little presentation on the research going on there. And after that presentation, that's a different topic. After the presentation, he told me, earlier I have sent 2 of our lecturers for PhD there, and they completed and came back. And Professor Samarbandhu was the supervisor. And he told me, your guys are brilliant, no doubt about that. This time also I will take one more guy from your department to do the PhD. But he said, he has a lot of other people like Chinese, Indians working under him going for the PhD. He said, but I noticed something about Sri Lanka. He said, I noted something working with Sri Lankan students. They are brilliant, no doubt about that. Given enough time, they will quickly pick up the job. But most of his research he is getting from other Canadian agencies or companies are problem oriented. That means the industry has a problem, they give money to the professor and he has to do research and give the answer back, solution back. That's how the research is done in other countries. And he said, when I give them a problem coming from the industry, they take a long time to understand, but short time to get the solution. Whereas Chinese, Indians, they take a very short time to understand the problem, but take a long time to find the solution. So therefore he said, it's not bad, our guys are good, he said, but the problem is, in order to understand the industrial problem, our people spend a longer time, and he has found out the reason also. He found out that his observation is that they are delayed in the start. That was his observation. They say they delay their start, saying that until you get the full understanding of the problem, I am not going to start. That is how Sri Lankans think, according to him. Right? I don't know, because I had been always with the Sri Lankans, so I did not notice. But he told me because he had been with a lot of other people. What does that mean to us? It will happen to the project also. Why I said that I heard it two days before. But at the same time I noticed that the projects people start projects long time after they complete the theory sometimes, 2 years later. Maybe it's the same reason, we are delayed yet to start. So one advice I would give is, give it a head start right now. Don't delay. Don't wait until you finish all the theory to do a project. And you can start now. So remember his comments, and I think it's valid for our project also, because last year only 3 people completed the project so far. Others have not started. Why? Why? We feel that we are short of money, isn't it? Sri Lankans are, they say, poor compared to other countries. And we feel that, okay, if we had more money, we can do more things. We are poor in money, but we are not poor in money. We are poor in idea. That's why we are poor in money also. So, in the telecom project, when you try that also, don't be poor in ideas. Try to generate ideas very quickly and refine on a project and then embark on that. Later we can do the correction, because project will take time, and within that time you can keep correcting. Don't wait until you study all theory of project to start. My worry is, why only 3 people complete? And why did the others not start? Maybe people are short of ideas, I am guessing. Because the responsibility of the idea is yours now. You have to come up with few ideas and then just check with me whether that idea will work, or will it be enough for City and Guild. Then I can advise you whether that can satisfy the requirements or not. After that you can embark on the project and do it. So please keep this in mind. So you may be one of the 3, right? Because I am not expecting a lot of you to finish the project even this year, right? Because that has been the tradition of Sri Lanka. But if you are aware about this, you can change this situation. So my advice is, don't delay a moment. Start thinking about the project right now. I will give very basic guidelines for today to start thinking. First idea is, now this project, especially industry oriented. It's not done on the paper, not classroom exercise. It is industry oriented project. That means you have to work and interact with the industry. Okay? This is one feature of British education system, where they have some kind of practical component built in for you to get familiar with the industry. Okay. We have to find, the idea of the project is this, to provide an opportunity for you, for the candidate, to analyze the corporate means industry requirements for telecom and network information systems. So those are the 2 areas we can focus on. Information systems, networking, telecom, those areas. And propose a global solution to meet the company's needs. So your outcome of the project will be a proposal for a solution. Which means, a lot of people misunderstand. A lot of people understand that I have to give a solution and implement it. You don't need it. Implementing a solution needs a lot of money, and they don't expect you to invest that much of money for the Cambridge exam. You are supposed to prepare a report detailing a possible solution and submit it to the company and City and Guild solve. That is the process. The misunderstanding is, I have to propose a solution, then I have to implement and show. It's wrong to think like that. You don't need to implement. You don't need to implement. But you have to justify that your solution is fitting into the problem and giving a solution to that problem. Yeah, it's a kind of consultancy where you propose a solution to the company. Yes. And that ability will be very good for you later. Seeing a problem of a company and analyzing it and proposing a solution is a very vital ability, and an engineering person should have. How many times you go to a doctor, isn't it? To get what? You have a problem, not a corporate problem, a human problem now. And then you go to a doctor, consult him, get the little advice and maybe some medicine also, and try to get the problem solved. So this is like the doctor's role. is the doctor healing your problem? If you have an ailment, is it the doctor healing? No. Healing happens to yourself. It's your own body fighting against the disease and healing. Doctor is giving the advice and support, that's all. Same thing here. You will be giving the advice and a recommendation to the company, and you are not going to solve that problem. Solution will be implemented by the company, not you. So it's the doctor's role in the form of an engineer. The role of the engineer, consulting engineer, is exactly this. When a problem is referred to you, you analyze it, and then you have to give a solution. Later you will have to face a lot of these types of projects. For example, even though I am very old, I am still getting little projects like this. Last week I had a project from Kalani Cables. Kalani Cables had been manufacturing coaxial cables for a long time, and they had been exporting it also. But some big cellular companies in Sri Lanka like Orbital, Dialog, and those people have bought this cable and installed in their towers. But when it comes to third generation, which is operating at about 2 GHz, when they cover the cable at 2 GHz, they suddenly find big antennas. And all the cables will have to be replaced unless some solution is solved. It's a big problem to the Kalani Cables, and they wanted to consult me, and I had to go there. Still I didn't find the solution to that. I'm still studying. But it's a little project, isn't it? Little project. A corporate problem is there. I have to analyze, and I have to give a proposal, and I am not going to manufacture the cables again. They manufacture. I give the recommendation. So those are examples of what you will be required to do later in your life as an engineer. And this is the opportunity for you to get trained for that. Think like that. So when you do the project with that thinking, you will enjoy it. Otherwise it will be a burden. So make it enjoyable in such a way that you keep that in mind that, okay, I am going to do this many times later as small project. Only in this one I am going to submit it to City and Guilds, but the future ones I am going to submit to the companies and earn money out of it. Consultancy is the third largest business in the world, isn't it? Therefore, you can earn money by proposing solutions. For example, if you look at big companies like IBM, how do they identify them? They say, we are solutions company. They say, okay, we are providing solutions for this. So even bigger companies are doing that. And you are doing it in a very small manner in this project. So start with. It's a very good opportunity. Too good to be wasted. Okay? Too good to be wasted. Okay. First point is that it should be corporate. Maybe you can write few important points, not the same sentence. First important point is that it should be an industry project. Should be an industry project. Yeah, last year also I did it, but not many people did it. If you did not do, maybe you missed something. Right? So better to listen very carefully. Those who have started have gone through and they have got their marks also. Others are still to start it. And that means that you missed something last year. Right? So listen carefully. Right? One is that it should be a company project. Second, area should be telecommunication, networking, and information system. So any of those big areas can be chosen. Right? Outcome is, next point, outcome, the report. Proposing a solution. I show you few reports also. The report proposing a solution to an identified problem in the compare. To an identified problem in the compare. Next point, use diploma and advanced diploma knowledge. You may have knowledge about the antenna, knowledge about networking. You can combine the knowledge. The idea is you have to apply those little pieces of knowledge you collected into this project in a suitable manner. So what they say is it should not be something totally outside the syllabus. Should not be something totally outside the syllabus. There must be some relationship with the knowledge you obtain from the syllabus of diploma and advanced diploma. Then you might have a question, I am still doing an advanced diploma, how do I put the advanced diploma knowledge? So that is where people delay the start. Don't think like that. Don't think like that. While doing advanced diploma you can apply, because if anything you can refer. If something is not done yet, you can still refer that little part needed for the project. So don't delay because of that. These are the aims. The City and Guilds aims to do this while doing this project. One is that they want you to acquire communication skills so that you can talk to industry people. Sometimes you want somebody give you a contact, okay, you talk to so and so, that manager, he might give you an opportunity. So then they take a call, he may be at the middle of a meeting, and you say, I want to do a project with your company. That person will be very angry about it. He will say, no, this is not the time, call me later. And there is no later. Every time you call, he will say, I am busy now. We know that you are a nuisance. This is bad communication skill. First thing you have to ask when you call a person or a manager is this a good time to talk? Lot of people I know, they never ask like that. And lot of my MBA students also call me while I am in the meeting and say, can I meet you tomorrow? I say no and cut off. Right? And after that I make sure that I don't give him another appointment for 2 weeks for doing it wrong. Because anyway they are MBA people and they should know how to talk to the protocol, right? So communication skills, very important, and I am sure a lot of you still have to train on this thing. Some of us are very rude in the communication and it annoys the other person. And sometimes we don't care what he is doing. This is my question. I am asking. Don't do that. That will be the end of any client. So you have to first check, is this a good time to talk? Or can I leave a message to your secretary? Or can I get an appointment from your secretary? Something like that. You should phrase it in such a way that he likes to continue talking with you. That's the communication skill you need to gain from the project. Because you have to get the appointment from this company. And some of you don't start because you find it's difficult to get in touch with the company. One reason is you might not have contact. It's bad. According to City and Guilds, it's poor show. You must have few contacts. At least somebody who knows somebody in that company. Likewise. Because contacts get the things done, not the knowledge, not the theory. Contact. Okay? You must have contact. You must have developed good way of speaking. And you must have to maintain that you stick to the time schedule. If he says, come at 10 o'clock, don't go at 10:30. Okay? That's bad management. That's bad planning. Okay? So there are a lot of things there which is not coming in our syllabus, but you will learn hard way by doing it. That's one area. Acquire experience in the methods and techniques of product in the company. Acquire commercial awareness, like your project report should have some money concern. How much can I save from this service? How big is the investment for the service? That kind of thing must be. and develop your personal qualities like trying to understand a problem, trying to formulate a solution, that kind of thing. So these are the aims of the yoga. And they are very valuable, you can see, because they cannot be taught. Someone can guide you, but no one can teach you this. Because if you teach someone on these things, he can never be above you. But on these things, you all can be above me after you do the project. Because these things are learned by doing, not by listening to someone. Right? Therefore, I am going to stop now. So there is no point listening. Therefore, I am going to stop at this point. But I think I have clarified the aims of the project that City and Group is looking for. Next time I will give you some more insight about the specific areas of project which has been done, and maybe I will show you one or two reports also, the format, things like that. And already, if you are a member of our City and Group, already there is a report in the files section. Go to the files section of our mail group, and there is one report I have posted already. You can download it and go through. I think I have put the proposal, not the report. Only the proposal is there. I will put the report also. And if you are not a member of the email group, please submit your email and I will add you to your group. There are a lot of files to scan, right? And one of them is on the project area. Are you getting emails from me? You are. How many of you are? Nice. What are the others doing? You gave me your emails. So you should have been getting. But some people have changed their email address, I suspect. Okay? So if you change your email address from last year to this year, please resubmit the new one. I have to delete the earlier one. We may be still going to that earlier one and returning. I suspect that. Okay? Those who are new, if you have not given the email address with you, I will add this within about 1 or 2 weeks. And then you can go to the files area and download this information. Okay? So that you can do from anywhere. Okay. We will call it a day. Thank you very much.